Hello, my name is Ed Suhler, and I am Vice President of Defense Systems and co-founder of Mission Secure Incorporated, a company located in Charlottesville, Virginia, with offices in Houston, Texas. Mission Secure delivers the leading ICS and OT cybersecurity platform. Mission Secure brings visibility, response, and control to enterprise ICS and OT environments without impacting operations. Today, I want to speak to you about the project that we've been working on over the last couple of years with NAVC on protecting and providing resilience for industrial control system networks, including those on shipboard systems. Mission Secure brings over a decade of experience in providing cybersecurity solutions for OT and industrial control systems networks and systems. We reduce the risk of human errors, insider threats, and targeted cyber attacks. In 2010, the Department of Defense sponsored a multi-year effort at the University of Virginia to provide unique and novel solutions to Stuxnet-like attacks on control system environments. The effort, led by researchers now at Mission Secure, was successful in showing how we could detect Stuxnet-like cyber attacks and control systems and begin to provide protections and resiliency to critical system functions. We initially used an unmanned aerial system as the example control system environment. That successful project culminated in the creation of Mission Secure in 2014 with a mission of bringing concepts created in our research efforts and our work with DoD out to help protect cyber-physical OT control systems across the defense industry and the commercial industry as well. Mission Secure has brought together people from a wide array of technical fields, including systems engineering, operations, network engineering, and cybersecurity to solve the problems unique to the OTS and ICS network systems world, ensuring that systems continue to operate in the face of continuously increasing number of threats and sophistication of cyber threats to the OT world. The result of the work done over the last 10 years is the Mission Secure Eagle Eye platform shown on the left. The Eagle Eye platform is a combination of software, hardware, and virtualized services that provide cybersecurity solutions to OT, ICS, and control systems and their supporting networks and devices. During this NAVC Phase 2 SBIR effort, we focused on implementing this hardware and software solution into the industrial control systems environments that are used to control naval ships and naval payload systems on board various types of vessels. We focused on navigation, propulsion, and electrical distribution systems as potential cyber targets and for demonstrations of the cybersecurity features that the Mission Secure solutions bring to those types of control system environments. The challenge posed by the Navy was, could a solution like ours be used to protect the operational technology and supporting control system environments to assure that physical components and their functions would be resilient to cyber threats and attacks and continue to operate on warfighting vessels and weapon systems even in the face of an active cyber attack. Also, since there is a commonality across controllers and different applications within the defense world, could we do this and provide that same resilience to not only weapon systems or for other ship systems, but also for other systems across the military, such as facilities, logistical support systems, weapon systems, both manned and unmanned, and apply the same methods to ensure mission success in those systems while operating in potentially cyber-contested environments. Most of the U.S. Navy's industrial control system and OT environments have not yet faced a sophisticated adversary. Systems that are in place were built for efficiency and ease of use by the operators, but they provide poor visibility into the actual OT network health and poor cybersecurity to protect them, and rely on air gaps that are frequently shown to be insufficient, and supply chains that are increasingly muddled with parts from unfriendly nation states. Unlike our IT networks, which have had years of tools and applications applied to them from a cybersecurity perspective, OT systems have very little cybersecurity tools available to help protect mission-critical systems and functions. Instead, we rely on traditional IT practices and tools to help in the OT environment. And while these methods can add value, they do not solve the cybersecurity issues that make OT environments vulnerable, and they do not protect system functions during an event, and they can potentially harm the processes that they are actually trying to protect. As our cyber offensive capability in the cyberspace continues to develop, they in fact outpace the defensive tools that we have available to help protect our own critical infrastructure. We will face powerful adversaries out there in the real world, sophisticated nation-state actors that will want to do harm to our industrial systems and our critical infrastructure. The controllers that are manufactured and that run these systems have products in them with varying levels to no levels of security built into them, and a supply chain that is insecure. There are also threats from the IT networks that are often attached to OT systems that provide many vulnerabilities for an adversary to exploit and to escalate their capabilities and ultimately take control within the industrial control system itself. If our red team can successfully attack someone else, then a sophisticated nation state can surely successfully attack us. The work that Mission Secure has done with the Navy, the Air Force, and with other commercial customers in the maritime, smart city, and industrial control system space has focused on answering this question. How do we make our systems resilient and protect them when adversaries successfully gain access into the control system environment? One of the most critical areas that must be addressed is the addition of a new layer of security that is complementary to the typical IT barrier approaches that focus on keeping the bad guys out of the system. This new layer provides additional capability to the operations environment so that the system can operate even in the face of a cyber attack. These include data visibility and the ability to get that visibility all the way down to the lowest levels within the control system. Detection and protections pushed down to the lowest level in the environment, right near where the physical process happens and the impacts of an attack can be felt. The next step is building in system resilience so that the system can operate even when something's detected and help it fall back to either a safe mode or to insert corrective actions that is either decided by operators or is inserted to the system automatically by the security platform. We also need to deal with the fact that we have size, weight, and power limitations in various types of operational systems that will differ between a large ship, a small ship, an unmanned aerial system, and a manned vehicle. And each environment will have its own size, weight, and power capabilities. What's needed is a unified system from a security perspective that can handle different types of controllers, different types of systems, not be reliant on reach-back technology, reach-back systems to provide protections to the environment, and most importantly, those protections cannot impact operational systems. This new and novel layer of cybersecurity visibility and capability offers the systems operator more than just new cybersecurity features. This project has shown that other features supporting things like predictive maintenance can be based on the same information that is being continuously monitored for security purposes. So the data can be used to predict when the system is going to fail and also help to classify when an incident recurs, whether or not that incident is cyber-related or just the result of a system failure. In this effort, we partnered with ABS, the American Bureau of Shipping, to show how we could, 1, securely collect sensor data from the lowest levels within ship environments, 2, use that information and artificial intelligence and machine learning techniques to use the same information that we use for security detection to instead predict system failures before they occur, and 3, to begin to classify incidents as either cyber or system failure related. This work continues and will help to guide system operators on incident response out into the future. The platform approach that Mission Secure employs is a bottoms-up approach to cybersecurity. We start at the lowest levels of the OT system and use sensor and device data from the devices below the controllers to validate what the network side, the more vulnerable side of the devices, are reporting to the operators. For example, a switch that is reporting is on to the operator when in fact it is really off. We also use patented methods to correlate what different sensors are reporting within the system and look for inconsistencies that might indicate a cyber attack. For example, on a UAV system, such as the vanilla long-range drone system that is currently being tested by NavAir and that Mission Secure is providing hardening for, we can constantly monitor and run voting algorithms for multiple position navigation and timing sources of data for the systems. And this can include multiple GPS sources, information from the inertial navigation systems, information from other satellite constellations, and other information sources, all to validate the actual location of the aircraft in an attempt to thwart potential spoofing and jamming attacks against the command and control and payload systems for the UAV. Our system provides a fallback, a more trusted source of PNT data. This bottoms-up approach, which complements the important but more traditional barrier approach to cybersecurity, where we focus on keeping the bad guy out, provides true resilience for critical system functions within the control systems, providing protections right at the impact point within the lowest levels and the physical devices within the control system environment, and it begins to address those systems working when a cyber attacker has found a way in. These same concepts apply to control systems across a wide array of both legacy and new systems. Building systems, transportation systems, energy distribution and generation systems, logistics, as well as ships, planes, manned and unmanned vehicles, weapons platforms, all share common vulnerabilities and can share a common mitigation strategy that uses this novel approach. Other organizations across the Navy, NAVSEA, NAVAIR, NAVFAC, across the Marine Corps, across the U.S. Air Force and its facilities, across the Coast Guard and the Military Sealift Command are just some examples of where this new technology can be applied to help protect the control systems that service their devices and their processes, both at home and abroad. I mentioned earlier that the same methods and solutions that protect ships and industrial control systems can be used to protect other more specialized systems. An example of this is shown in our efforts with NAVAIR under a separate series of SBIR Phase 2 projects, where Mission Secure has been providing our leading cybersecurity products and capabilities to cyber harden and protect a long-range ISR drone system called Vanilla, together with our partners at Platform Aerospace and Progeny Systems. Vanilla, which is a drone that can fly up to 10 days, along with our cyber protections that cover supporting ground systems, ground-to-air communication, and the autopilot onboard payload systems, have been undergoing flight tests for the last 2 years in order to prepare for operational deployments. The approach outlined in this report and the list of security features shown here are very similar to those applied to the control system environments for ships in our research during this effort. What is different is that the hardware-software portion of the solution has been miniaturized to fit within the size, weight, and power requirements of that unmanned system. This capability has also led to innovative solutions for securing and providing dynamic management of the communications between the air system and the ground. The successful work that was done under this SBIR effort with our partners at ABS reused sensor data that the Mission Secure platform securely collects for cyber detection and instead used it for predictive maintenance purposes. By using powerful artificial intelligence and machine learning techniques, we can further emphasize the value of the cybersecurity solution beyond cybersecurity alone. The application of AI/ML to this new layer of system data that is being continuously monitored throughout the control system environment provides the ability to both identify security and system failures before they cause an impact to system functions. They also bring together data or fuse data from all over the system, including network and non-network data sources, and do more sophisticated detections. In our efforts with both ABS and the Hume Center at the Virginia Tech University, we are researching new ways to use AI/ML not only to build models that will help detect these threats in specific systems and specific circumstances, but also use new transfer learning techniques to take the things that we learn about a system or a detection in one environment and transfer those techniques to another environment without human intervention. It is a secure collection of data from the Mission Secure platform at lower levels within the system that enables these types of new features and capabilities and provides a place to embed these techniques into the operational systems without having effects on the operations themselves. Mission Secure has technology that is currently deployed commercially in the maritime, smart cities, and oil and gas industries. Our solutions are at TRL 8 and 9 levels and are tested in operational environments around the globe. Our solutions that have been created for NavAir have been deployed for unmanned systems and are at TRL level 8 with flight testing that is concluding this year and ready for deployment. The solutions we have implemented for this project at NAVC is an application of those same solutions already implemented in our commercial maritime customers. We are actively looking for places to take the work done in this effort and with our current customers and take it and apply it to operational ship environments across the Navy, the Coast Guards, and Military Sea Lift Command and progress the SBIR work to phase 3. We are also working with our partners across the government and defense environments to provide this new capability to control systems in the military systems, manned and unmanned systems, and across the critical infrastructure system in the United States, but both at home and also abroad. The SBIR Phase 2 work that we have completed has demonstrated how our cybersecurity platform provides the following benefits for control system environments such as Navy ships, manned and unmanned platforms, facilities, and other cyber-physical environments across a wide array of different applications that allow humans and machines to control their physical processes securely. We provide monitoring of sensor data, network data, and we monitor the physical behaviors of the system to provide multifaceted anomaly detection within the control system that is protected. Second, we provide sensor-level integrity, which enables data analytics, predictive maintenance, and other use of data in a secure environment. Third, we provide threat detection and a blocking system to keep actions from the cybersecurity adversary from having effects on the system at all times. Fourth, we minimize the effects of successful attack. By protecting the critical system functions within that cyber-physical environment, we push resilience to each one of those functions out to the edges. We provide one security platform that provides protections across multiple vendors' systems in the control system environment, thus reducing engineering costs and allowing for ease of operation. 6, we provide enhanced data collection in secured environments for better maintenance decisions, thus reducing downtime and costs related with maintaining important system function. Mission Secure brings services to the Navy through subject matter expertise in identifying OT and control system vulnerabilities and providing for secure designs for OT systems. This includes the ability to provide 24/7 monitoring and incident response, as well as technical support for those customers using our systems. We leverage our commercial experience, and we provide reliable performance and high-quality control, and we leverage the experience we have from an academic, engineering, and practical experience to provide sustained services at low risk for the Navy and for other customers that use our systems. If you look across the cybersecurity marketplace today, existing systems and those currently in development use sensors designed with very simple parameters to show the current health states. There are many companies that can design and deliver linear decision algorithms, so few that can validate sensor data or affect the proper data labeling and sensor requirement planning to support sophisticated models. Other companies with machine learning capabilities espouse theory but haven't developed and commercialized robust solutions. Our competition in this area lacks researcher and practitioner experience with the combination of machine learning, prognostics, and system health management, OT network cybersecurity, network communications architecture, and unmanned systems expertise. Our multidisciplinary approach not only brings a powerful capability to Navy vessels, but to many control systems that lack cybersecurity capabilities, solutions, and the people to understand the intricacies of applying cyber to OT environments without causing effects to the system. We would like to thank the U.S. Navy, NAVC, the NAVC SBIR office, our TPOCs, Jake Sylvia and Rick Zabrowski, and the SBIR Transition Program for giving us this opportunity to share the story of the valuable work done under this SBIR Phase 2 effort. Between the commercial and the defense applications, Mission Secure's platform is poised to change the way we protect and provide resilience to our most critical OT, ICS, and control systems environment. Thank you for your time.